my name is Pedro. I'm currently doing the PhD at Maastricht University in the field of clinical data science. And today I'm going to give an overview of our work to harmonize the data of multiple cohorts using the OMOP common data model and to establish a federated learning network for dementia research. In case you're interested in checking our work in more detail, it has been recently published in the Journal of Biomedical Informatics. And so starting with the NCDC, the Netherlands Consortium of Dementia Cohorts, it brought together 9 cohorts with relevant data for the study of dementia. The main goal here was to leverage this larger and heterogeneous data set to perform analysis on aging and dementia. So to achieve these, different strategies were considered. So the more traditional, to perform this kind of analysis would be for the researcher to directly receive the data, or even to travel to the institute and directly work in their secure environment. However, with recent concerns with data privacy and regulations, this can limit the data that can actually be shared. If we think about imaging data, this is even more challenging. And so one of the approaches considered was to perform federated learning across the cohorts. So in this strategy, the data remains in each institute, the analysis is performed locally, and then only the results are shared with the researcher. So no data is sent to the researcher. In practice, NCDC grouped 9 cohort studies with data from more than 40,000 participants from the Netherlands. The type of the cohort studies was diverse as the data included, so different types of data that were considered relevant for the study of dementia. And then it also included imaging data, in this case, MRI scans. And then to be able to perform federated learning, there were 2 main action points that we had to look into. So one was the federated infrastructure, installing the software at each cohort, connecting the database, preparing the algorithms to perform the analysis. And then the other was the local data extraction and harmonization, so make the cohorts interoperable. And here there were a few questions regarding should we use a data model, which one, what type of database, so should we standardize the data, what ETL tools are available. So this is not usually very common for cohort data. And although our main goal was to make these cohorts interoperable, we also wanted to improve their potential interoperability with future cohorts that also standardize their data, also comply with the FAIR principles, and to focus a lot also on reusability of the work that was being done. So after exploring and trying out a few options, in the end we considered, and considering the data that we wanted to harmonize, we decided to move forward with the OMOP common data model. Unfortunately, we didn't find a strategy or an ETL process already developed that we could really apply to our case. And so this was both because of the federated approach, so we have limited access to the data. The data stays in the institution, but also since in many cases the ETL tools can be database specific, so we had some difficulty here. And so we decided to follow a strategy where we separated the different components. So the consortium decisions for the data that we want to include, the cohort metadata itself, and then separately the ETL scripts to transform the data into the OMOP common data model. And so focusing and giving an example at the consortium level, so what was done was first to select a set of variables that was necessary and considered relevant for the analysis, and then making a choice on the standard vocabularies and concepts that we wanted to use to represent. And so we created this consortium OMOP mapping, where each variable is linked to a concept ID, the same for the units or also the values. So having this overview of how we want to represent the data in the final model. At the same time, at the cohort level, we collected the metadata for each cohort. So we created this table that could be filled by the experts in the cohort, and they would provide the information on the actual data set. So here we collect the variable names, the values that are used, etc., in order to be able to then map them to the correct concepts in the OMOP tables. And so with this information, we then could move forward to perform the ETL process. And so first, with the number 1 there, so it represents how we created a consortium mapping that was mentioned before. The section represents the process of checking the set of variables and then which concepts and standard vocabularies are the best match for each variable. So here we use the Athena and Usagi to be able to build this consortium mapping. Then in number 2, so in each cohort, we put together the cohort metadata, the cohort data, and the consortium mapping together. And this is the input to the ETL tool that we developed. So the tool will first identify the data fields, perform some data transformation, so mapping the values, converting the units, or aggregating data if necessary. And then afterwards, standardize the variables, values, and units, and identify the domain on the OMOP database, and then populate it. An important part here was really to try to make the ETL tool agnostic to the cohort's metadata and also the consortium decisions, so that when we go to each cohort, we would only change, of course, the input here and be able to harmonize the data there without changing the ETL tool itself. And then as a small note, just to let you know that the ETL tool is open source and it consists of a command line interface built in Python, and it's available on GitHub. And so as an overview of the achievements that we did, so we were able to harmonize the data of the 9 cohorts and create an interoperable network using OMOP. The federated infrastructure was also successfully installed in all of the cohorts. We were able to connect them and perform federated analysis and also run federated learning algorithms. But of course, this journey presented its share of challenges. So the process described before was a lot modeled by these difficulties and trying to find a path that would facilitate our goal. So, for example, at the cohort level, we had difficulties due to the data access methods, security rules, software tools that were available. This could be very limited. The data structure between the cohorts was also very different. The legal agreements for a method like federated learning was also not that easy. And then focusing on the OMOP and the standardization process, we had big difficulties with the complexity of the relation structure, not exactly for ourselves, but to explain it to the researchers on how to use it. Then also the fact that we weren't able to find standardized concepts for a lot of our variables. There's not exactly a consensus on standardizing these concepts for the field of Alzheimer or dementia. And then this was expected, but we also needed to make some adaptations to represent the cohort data. That's not the main goal of OMOP, but there were a few changes that we had to make. And just to conclude, I'd just like to share this overview of the journey and how we are currently using the network. So this started in 2021 with the planning for the federated infrastructure and the data harmonization strategy. It took some time and effort from all the parties involved. And then finally in 2023, we were able to run the first application to train a convolutional neural network and also perform association analysis using the database. And then now we are already running a new analysis with linear models and also continuously looking for ways to improve what was developed. I'd also like to leave a thank you note to everyone that was involved in making this work possible. Thank you.